Hi, everybody. I'm Ken Heath. I'm Business Development Manager with Collins Aerospace under the Goodrich de-icing and specialty heating systems for Collins Aerospace. And thank you for attending this IA renewal on installation, care, and maintenance of pneumatic de-icers. So I wanted to start off giving you some product information on de-ice, some generic product information that you may or may not know. It never hurts to refresh though, so we'll work through this first and go from there. A lot of people don't realize on the surface how much is involved in a de-icing system on an aircraft. In this particular illustration that you see here, you'll see that the aircraft has quite a number of components that are called out on there for the de-icing system. Now, this aircraft is a more complicated aircraft. Most of what you would typically deal with is not going to have this extent of de-icing system on it. However, there is at least one or two of these components on every aircraft de-ice system. So you have to keep that in mind, be cognizant of all of that information as you do maintenance on the aircraft de-icing systems. So what does it consist of? Well, this is your basic system if you were to just pull it out of the airplane and compress it. The key point here is that the system is always working. When that aircraft is running, the system is working, whether you're actually using the de-icers or not. The aircraft will at least always be pulling vacuum on the system. The de-icer types, there are different de-icer types. It's not just a rubber boot that goes on the airplane and that's it. There are some specifics to the de-icers depending upon the aircraft type and the mission of that aircraft. The most common that you'll find out there in the market is the black neoprene rubber de-icers. This is usually mostly for all standard configurations on aircraft. But what we have out there as well is a material called Estane, which is basically a polyurethane type material that Goodrich invented back many years ago. And this material is a little bit more robust than the black neoprene and is oil and fluid resistant. It will improve the ice shedding on the aircraft, and it reduces any cold cracking in instances that could occur with the aircraft. In the case of the oil and fluid resistance, you'll find sometimes on aircraft, and a Dash 8 would be a great example, you'll find that the Estane is not necessarily used on every position of the aircraft. You may find it just in areas around the engine, the inboard portion of the wing, any place that could be susceptible to blowback of oil or any kind of diester fluids that would come off of the engine. And then the last thing we have available out there is silver urethane. And what this is a rubber boot that has aluminum oxide metal flake that's impregnated into the rubber. And it gives the appearance of a silver leading edge on the aircraft. And as noted on this Phenom 100 showing on the screen, those are silver de-icers that are used on that aircraft. It's a premium appearance, and quite frankly, it's about the same in performance as what the black Estane would be, except that it's silver. So really, it's mostly for cosmetic purposes, not necessarily for any kind of improvement in icing performance. So how does a de-icer work? Again, most of you probably know this, and this is elementary, but it's always a good thing again to refresh on. So you have this wrapped around the leading edge of the aircraft, and of course it's a rubber ply, has inflatable tubes within that rubber. You can have simultaneous inflation de-icers, or you can have alternating inflation. You'll see a difference in the way the boot operates. So for instance, on a Piper PA-46 500 TP, that is alternating. You'll see the tubes inflate on the top portion of the de-icer, and then they'll vacuum in and they'll expand out on the lower portion of the de-icer. The same on the Pilatus PC-12s. Whereas on something like a King Air, you'll just see the boot inflate all on its own at one time. Your inflation pressures typically will range from 11 to 22 psi. That will vary according to the manufacturer specifications on the aircraft. Most aircraft typically run in the 18 psi range. Some will be lower, like Pilatus, I believe, runs around the 12 to 15 psi range. But most in cases is only 18 psi. You don't need a lot of pressure in these boots. The reason for that is just any amount of movement under the ice will crack that ice and cause it to blow off of the aircraft. So that's why you don't see higher pressures in a de-icing system. You need just enough to get those tubes to inflate about 3/4 of an inch to an inch off of the leading edge, and that'll crack the ice off. Then you have tube type or sewn carcass type de-icers. All the original de-icers that Goodrich had made going back into the 1930s was actually a tube type de-icer, and it's fused, and it's very similar to what a bicycle tire inner tube would be, and you have those laid out in rows on the leading edge, and it would blow back the ice in those cases. But in this particular case now, with the sewn carcasses, it's a little bit more robust. You have a material inside of there that will give you reinforcement and will allow the tubes to expand fine without any problem, but you don't have the wear that you would normally have on a tube type de-icer. So then when you apply it, of course, the tubes blow up and they then suck back in again and blow up and suck back in. So it's that simple. And if you look to the right on this slide, you will see some examples of the de-icers in our icing wind tunnel in Uniontown, Ohio. You'll see a clean de-icer inflating on the top picture. And in the middle, you can see probably the worst possible situation. I don't think anybody will ever see that. And if you do, you're probably in a world of hurt. But we test these de-icers to their limits. And so, we'll try to do everything possible to trip up the de-icer and see what the limitations will be for every particular aircraft. So taking a look at the construction of the de-icer, I've kind of mentioned a little bit of this before, but the de-icer will consist of multiple layers, not necessarily what you're going to see on this particular illustration. It could have more or less layers of material on the inside, but that thin piece, that 0.085 inch thickness is containing 5, 6, 7 layers of material in there, along with the air pockets and the sewn carcass and such that will make up the de-icer construction. The weathering surface can be a different surface than the natural rubber, obviously, within the de-icer. So you have different types of materials that are sometimes used on the inside of the de-icers. The key point here, though, is your stress concentration on all de-icers is going to be at that stitch line. And I'll talk about it a little bit further into the presentation here, but one thing I want to stress at this point is if one of those stitches are broken on the stitch line, or if the stitch line is not functional, if there's an issue with it, the de-icer will have to be replaced. That is not something that can be repaired. So how do you know what de-icer you actually have on the aircraft? Now, in our case, with our de-ice boots, we put this laser brand on all the de-ice boots, and it contains a lot of very important information. It will typically be located on the inboard lower portion of the de-icer. And it's going to help you to determine what the usage and the warranty is on that de-icer. Your first number there is your part number. So obviously there's a reason why you need that. The second is an OEM part number. So if it's, say, a Cessna aircraft, if it's a Baron or something like that, that they'll have the Cessna number listed in there as well. That's not always filled in. So it's the most important one is going to be the part number itself. The number in the middle there at the top is going to be the de-icer serial number. This is something that we will always ask for whenever you are inquiring about an issue on a de-icer or have questions about a particular lot number on a de-icer and such. And serial number is something that we're going to need. This is a really important one right here. This date that's going to be in the upper right-hand corner of all of the laser brands. This is called the cure date of the de-icer. This is not an expiration date. And I need to really stress that. We've had people that have thrown away perfectly good de-icers because they thought it was an expiration date. And it's not. This is when the de-icer was cured or manufactured, as you would also know that as well. So please keep that in mind. Again, another piece of information that that can be helpful for us to determine usage and warranty on the de-icer. Then you have the FAA PMA report number on here. This is just to prove to you and anybody out there that if you are purchasing a PMA part, it is in fact registered with the FAA as a PMA. And then the last thing on here is showing what the primary material is of the de-icer. Now, in most cases, you're not going to be too worried about this, if you're doing just basic maintenance on the de-icer. However, when you get into the care and maintenance of the de-icer, there are certain materials that we don't recommend using on Estane versus the neoprene de-icers. So if you want to be absolutely sure of what type of material your de-icer is, this is what you want to reference on the laser brand. In this particular case, it's showing that it is Estane. Otherwise, it would show neoprene, it would show urethane, whatever that material is. So it's good to check that as well. And don't assume that all de-icers on the aircraft are the same material. You need to look at each and every de-icer if you're getting ready to use a material, a cleaning material of some type that you're not sure can be used on Estane. Look at all of the de-icers because there is a mix in some cases. As I mentioned earlier, there can be a mix of de-icers on an aircraft. So looking at the features and the benefits, first thing we have on our particular de-icers, you got a 5-year or 3,000 flight hour warranty from the date of installation, and that's whichever occurs first. I think in this particular instance, the most important number is the 5 years, because quite frankly, the most aircraft in the business in the general aviation world are never going to reach 3,000 hours in a 5-year period. So you're probably going to get your 5 years out of that on your warranty. On regional aircraft, it'll be a little different because of the usage of the aircraft, the missions of the aircraft. It takes a real beating. The regional aircraft warranty will be 3 years or 4,000 flight hours from the date of installation, whichever occurs first. In most cases, the 4,000 flight hours on a regional aircraft will be the first thing reached. So you keep that in mind as you do your inspections and such on de-icers going forward. And as you can see, what we define as the business and the regional aircraft, the important thing is the regional is defined as 19 seats or greater in excess of 19,000 pounds mean takeoff weight. For storage on a de-icer, this is something that's a lot of times overlooked. Storage is very, very important for these things. Technically, a de-icer is considered an on-condition part. It really does not have technically, it doesn't have an expiration date. We allow, with the warranty, we allow 5 years storage on a shelf, and then the warranty would kick in at that point in time. Unless you install the de-icer on the wing, at that point, your warranty stated in the previous slide begins. So what I'm really saying is you can store these boots for like 7 years on a shelf as long as it's in its original sealed bag and container. And when you open that bag up to use it, then the de-icer should be just fine. If you get beyond the 7 years, we would recommend that you do an inspection per our 30-10-31 CMM for the product. The temperatures should be somewhere in a range of 40 to 80 degrees. I don't think anybody's storing the ice boots outside or in any kind of unusual circumstances, but we still have to make sure that's stated. And again, as stated before, up to 60 months, 5 years, with no loss of warranty on the shelf. And again, it's an on-condition part. You do not necessarily have to dispose of the boot if you're going to use it after it's been on the shelf for quite a long time. Again, you just do the inspection according to the CMM. And if everything passes according to what the CMM has stated, then you can go ahead and use the boot. All right, we're going to take a look at de-icer installation. De-icer installation, those of you that have done it, you're gonna, and if I was in a room with you at this point right now, I'd ask how many of you have actually done it yet. And so that's something that people like to do. It's a tough job, it really is. It takes some elbow grease, it takes some patience, it takes the right tools. And right here, as you can see, the de-icer installation tools that are required in our particular case will include your basic things, your basic carpenter type things, chalk lines, straight edges. You want to make sure you have lint-free cloths available, masking tape, 1 inch. We also, in some cases, use 2-inch masking tape on some things as well. But the important tools here are the rollers. The right roller makes the job a lot better. We've seen a lot of different rollers used, everything from linoleum rollers to things made out of weird materials, pipes, you name it. So the tools are an important part. And the technique in using those tools is also very important as well. So make sure that you pay particular attention again to 30-10-31, the CMM for de-icers, that will list these tools out as well. Also too, make sure you're using the right brushes. Don't try to skimp on the brushes. I'll go back to that in a second. You can see the brushes, the Worcester brushes, or the equivalent that we use for edge sealer and things like that. You make sure that you don't skimp on that, because again, it makes the job harder if you're not using the right tools. And that's what we highly recommend for the installation of the de-icers. The removal is the tough part. This is the elbow grease part. Make sure you follow the directions very carefully in pulling off the de-icers. Don't try to innovate new ideas. Some of the ones that I've heard actually compromise the structure of the aircraft, and I won't get into those, so I don't want to give anybody bad ideas. But follow these directions. So you want to debond the trailing edges first on these de-icers. So pick at that thing, get the trailing edge started, and get those all pulled up, and then go down the length of the de-icer with a hook knife or some kind of a knife that's not going to cut into the leading edge itself. Make sure that it's set at a depth that it only cuts the de-icer, and you're looking to score it. You're not looking to actually cut the whole thing off. Score the de-icer at the center line, and then you score the rest of the de-icers in strips. And those can be, 3, 4, 5-inch strips, up to 6-inch strips is easy to work with. Start at one end of the boot, and using a solvent, and this is a good 2-person job here if you have the person available. Get a squirt bottle with toluene in it. And as the boot is starting to be pulled up, start squirting the toluene in underneath the boot as the other person is stripping it off. And then once lifted, make sure you can continue to strip that the full length of the de-icer. So have that person follow you down the length of the de-icer with toluene, and that will really help in getting the de-icer pulled off of the leading edge. Use caution when you're getting around those air lines and air connections. There's a number of things that can happen there, and you just want to make absolutely sure that you don't cut a line, you don't crimp anything, you don't rip off anything. It's very important to be careful at that point. So before you begin the removal, and this is the big takeaway on this particular slide, before you actually begin the removal of the de-icer, take your new de-icer, your replacement, and make sure you dry fit it to the leading edge to be sure that you've got the right part, because there's nothing more heartbreaking than to get the de-icer pulled off of the leading edge and find out that the wrong de-icer was ordered, or there's something wrong in the box, or whatever the case may be. Because now you're sitting there with a hanger queen, and until you can get a new de-icer brought in to put on the aircraft. So again, make sure you always dry fit. Just take it out of the bag, lay it on the leading edge, have somebody at the other end hold it in place, and make sure that it matches up to the area that it's supposed to match up, both in the length and in the width of the de-icer. Leading edge preparation. This is probably the single most important part of this whole process. Make sure you cap your rigid airlines so you don't get anything in there, any of the solvents or dust or any kind of other FOD. Cap those things off. Remove the remaining adhesive from the leading edge. So when you pull a de-icer off, you're not going to get all the glue. The glue is just not going to come off of the thing perfectly. If it does, the de-icer is probably not stuck down well enough. But make sure you get all the glue off of that leading edge. To do so, what we would recommend for 1300L applications is the Purco 321. It's not a product we sell, but it's most supply, like aviation supply places will have it now. It's a citrus-based solvent. It's environmentally friendly. You'll get to check all your EH&S boxes when you use this stuff. And when you do use Purco 321, if you look at the picture in the top left side of this slide, make sure that you slather it on really good. Don't skimp on its use, because you want it to stay gelled. It's a gel when it comes out of the can. You want it to stay goopy, gelled, clumpy, and that's what's going to be best at breaking up that adhesive so that you can finish scraping that off. For the fast boot de-icers, that's the ones with the pre-applied adhesive on the leading edge. You want to use toluene or MEK. MEK is not around too much anymore, as much as it used to be, but toluene soaked rags. What we find is if you take those, soak the rags, lay them on the leading edge, that will soften up the fast boot adhesive and makes it a lot easier to get that residual adhesive off the leading edge. Then you want to prepare the leading edge per the aircraft maintenance manual. So, you might be dealing with different materials. You might be dealing with an aluminum leading edge or a composite leading edge. You may have to deal with fuel barrier cement in some cases where you have a wet wing. There's a number of things that could have to be done that is not covered necessarily in the component maintenance manual. So make sure that you're doing it per the aircraft maintenance manual. And as I mentioned about fuel barrier cement, the 74-451-99 is the fuel barrier cement typically used in a lot of the applications where you have a wet wing. Pilatus actually requires the whole leading edge to be covered with fuel barrier cement. So make sure that you're following the AMM for those instructions. So with the standard boot, the standard de-ice boot, this would be the glue on. Mask off your area with 1-inch masking tape. You want to mix your 1300L, and this is important. Make sure you mix that up good, because if you take a stir stick and dig it down in there, you'll get clumpiness at the bottom of that can. So make sure that you get all the clumpiness out of there. You don't want any of the solids in there messing up your glue job. You want your glue to look like what's in that picture at the lower right hand side there. Make sure that you brush your coats evenly to the backside of the de-icer and to the leading edge. And you want to let that dry for 1 hour. And then at that point, you can mark your center line per the 30-10-31 component maintenance manual. Then you can apply a second even brush coat to the back of the de-icer and the leading edge. Go ahead and let that dry 1 hour, and then you're ready to start the application itself. Very important point here, do not thin the 1300L. I know some people really like to cut the 1300L to either make it last longer or whatever the case may be, but that is going to compromise the adhesion of the de-icer to the leading edge. So please do not thin the 1300L adhesive. So doing the actual installation, first you're going to start with pulling the de-icer air connection line through the hole in the leading edge and apply vacuum at a convenient connection point to be able to do so, because you're going to do your application. You're going to do your application of the de-icer with vacuum applied. You want to activate your glue, your 1300L. You'll use a cloth dampened with the solvent, and the solvent basically is toluene. You want to do a 1 to 3 inch wide area by 18 inches on the center line. And then at that point, once you've got your boot lined up on your center line, then you could go down and you start rolling it on with the rubber roller. And note how the guy in the picture here is holding the roller. You don't want to hold it like you would a spoon or anything like that. You want to hold it like you would have a knife in your hand if you were trying to stab something, because you're going to get far more leverage holding it like that is in the picture than you are trying to hold it like you would eating a bowl of soup. So do it that way. It's going to make the job a lot easier. You can get a lot of pressure onto the leading edge that way. So you continue the process of working out from that leading edge center line. You want to work outward from that. So you just kind of go at slants along the top, and then do the same at the bottom when you're applying that portion of the de-icer. Now with the fast boot, we're talking about an entirely different process here. The fast boot has the adhesive applied to the back of the de-icer. Many of you have probably already used it. For those of you that haven't, it has, if you look at the picture in the upper right-hand side here, you'll see that it has a liner on the back that is stripped. And so you pull those strips off to basically apply the de-icer. But you want to mask off your installation area with the 1 inch masking tape. Mark your center line on the leading edge. And in the case of the fast boot, you're going to be referring to CMM 30-10-70 for the fast boot. And that'll give you specific directions that cover just the fast boot installations only. So you're going to use a primer. You see the primer here in the picture. The primer is a clear, thin liquid, not like the 1300L. You don't have to mix it or anything like that. It comes right out of the can as is. And it's basically a liquid form of the adhesive that is used on the de-icer itself. And so you'll brush that on. You want to put 2 to 3 coats of the 74-451-207 primer to the leading edge. And if you have a composite leading edge, you'll want to make sure that you get 3 coats on it, because composite will soak that up a little bit more than what the aluminum leading edges will. You only have to do this to the leading edge. That's it. You don't do like the 1300L. You don't attempt to put any glue on the actual de-icer itself. So you only need to let this dry for 5 minutes between each of those coats. So it goes pretty fast. By the time you get to the other end of the wing, you can probably go back and start doing the second coat on that other side of the wing and keep working back up again. The final coat should dry 10 minutes before actually doing the installation. And the install has to begin within 2 hours of the final coat. It does have a time limit on it. I mean, you got plenty of time to work with it, but you got to do so within 2 hours. So if for some reason lunchtime's coming up or whatever the case may be, and to make sure that you're not racing against the clock. Don't try to do primer on the leading edge and then go to launch. Make sure that you're ready to go with it as soon as possible. And then the backing paper on this, you'll see on the picture, the backing paper there. So it's slit so that you can pull it off in strips. But what you want to do is what we call crack the liner. And that is bend the de-icers so that those slits will actually crack and rip open if they aren't already. Because of course, when you're doing a slitting, we don't want to slit down into the de-icers. So they score the backing. So go through and make sure that you bend the de-icer the full length of the de-icer to crack that, to crack those slits and make sure that they're free of the one next to it. So the actual installation portion of this, you pull that air connection through the line in the leading edge. Again, just like with the 1300L, you do the vacuum at your best connection point. And with the release paper facing outward, as illustrated in the top picture there, you'll want to start releasing the paper on the center line. And you can see how they're matching the center line of the de-icer to the center line that you have drawn on the leading edge. And you start rolling that de-icer onto the leading edge. And as you can see at the bottom there, that's what it looks like whenever you get the just that portion of it adhered to the de-icer. Or I'm sorry, to the wing. You'll want to use an assistant with this if you can to hold and release that paper as the other person's rolling it. It makes the job far easier to get that thing set. And you got to make sure you follow that leading edge line perfectly, because even if you get off a little bit at the beginning of the roll, and as you know, it's going to expand further and further the more out you go. And so by the time you get to the other side, you could be 2 or 3 inches off the center line if you don't make your correction when you have to at the beginning. So always make sure you're following that line perfectly. So press that center line or de-icer onto the center line firmly with the rubber roller then after you've gotten it set on there by hand. And then as you did with the glue on boot, you're gonna work outward from the center line. So again, you're gonna be pressing with that roller, working hard at an angle on the top and then the bottom, however your technique is for applying the boot. And then to do the finishing portion of this thing, you got to trim the de-icer if needed, and that trim would include something like stall cutouts. Sometimes you got to trim the de-icer on the wing itself. There are some cases where we leave dead area on the de-icer at the ends to accommodate any expansion and contraction, or any of the differences in lengths. With a de-icer, it's not a perfect part. There's probably an inch or two of allowance that's given for the de-icer, and then a lot of times we put a dead area on the de-icer in order to allow you to trim that thing off. So once you got all your trimming done as needed, if you have to do any fillers, for instance, on a Pilatus PC12, it's a recessed de-icer into the leading edge, so you're going to have to do some fillers in that leading edge, and make sure that you are doing it to the thickness of the de-icer edges when you're doing that filling. Anything that's associated with the adjacent aircraft structures, and then fillers that are around any of the cutouts that you've done. Recessed edges, just like I mentioned on the Pilatus PC12. And if there's 2 icers on the leading edge, again, you'll use a filler in between those de-icers. So you'll do all that first and let that get set up appropriately and such. And then you'll apply the conductive edge sealer. And again, that'll be per 30-10-31. So the edge sealer, don't try to put paint on there or something that is not an approved edge sealer, because it is conductive. And you've got to have that conductivity, because the de-icers can build up static electricity if when flying through precipitation of any kind, you get the P static buildup, and if it doesn't have the ability to transfer into the structure of the aircraft, then what will happen is you'll get little snaps of electricity on the leading edge, and that will lead to pinholes in the de-icer. So you have to make sure that you're using the appropriate conductive edge sealer. And I believe the number on that is 74-451-11 and -11-1. So there's a pint and there's a quart kit of the edge sealer that you can get. As you can see in the picture as well, you see it's all masked off. When you take the de-icer out of the box, don't throw away the tube that's used to wrap the de-icer. You can actually use that to be pulling the tape up as the other person is painting on the edge sealer. You don't want that edge sealer to set up too long, because then when you try to take it off there, you'll get the cracking, you'll get the popping off there. You have to keep touching it up. While it's still wet, somebody should come behind you with the roller, with the tape around it, and roll that tape up as the edge sealer is being put down. That's going to make the job far easier and really nice and clean. It's just a far better look at the end. And then you do your functional check. Now that you're at the end of this thing, post installation, you'll do the de-icing system check per the aircraft maintenance manual. If you have put a fast boot on, you can fly immediately, or you can inflate the de-ice boot at 2 hours after the installation. So you don't have much of a wait time at all with the fast boot. If you've put a standard boot on the aircraft, you can fly the aircraft after 4 hours, but you can't inflate the de-icer for at least 48 hours after the installation. So make sure that you or your customer or you are abiding by these wait times, so that the de-icer has an appropriate amount of time to cure on the wing. So the features and the benefits of this stuff. I mean, the fast boot, it's a patented technology. We put it out like 20 years ago and such. So it's been around for a while, but there's a lot of good to it. You're not having to put all the layers of 1300L on. It's more environmentally friendly. You don't have all the hazardous waste that's associated with it and such. So faster installation overall. It does reduce the drive times, and the aircraft can be flown immediately and used in a much shorter period of time than it is with the glue on. So again, it'll reduce the solvent usage. And when you're trying to meet specific Environmental Protection Agency requirements, this is a good way to go to help to achieve those results and check that box. The primer for the fast boot is 74-451-207. So primer, pressure, patience. The slower you go putting a fast boot on, the faster it is. So it's not as hard as you would think. You just got to take your time. That's the key point to this whole thing. So we're going to take a look at de-icer repairs. This has always been an exciting thing to go over with people. I see all kinds of repairs, wrong type repairs, but we'll cover these right now. So the cuts and the tears in a de-icer, you can't exceed a 5-inch by 10-inch patch. So you've got an L shape or a jagged cut in the de-icer. As long as it doesn't exceed an area of 4 inches by 9 inches, you can repair that with a 5 by 10 patch. Basically, what that means is all your de-icer patches have to have at least a 1/2 inch around the damage in order for it to appropriately be repaired. If you're on a stitch line, make sure there's no cuts on the stitch line, or don't cut the stitch line if you're trying to clean up an area of damage to put a patch on. And pinholes not exceeding 1/16 of an inch can be repaired as well. So as you can see in this diagram, you gotta have a 1/2 inch around all the areas of the damage in all directions. If you have a cut or a tear in the fabric, on the de-icer, it has to be replaced. There's no ifs, ands, or buts about that. It has to be replaced in those cases. The patches are available in a number of different sizes, and these are the repair limitations on the patches. So this information is in the 30-10-31 documentation that we have. It is also in some cases in the aircraft maintenance manual. But for a nice visual check on our website as well, we have this diagram that kind of shows you a visual of how many patches are allowed in a square foot area. So 3 small ones, you can use 2 medium, or a medium, 2 smalls, or a large. So you can put quite a few patches on a de-icer. It's just that you have to make sure that you're doing it within the limitations that are called out in 30-10-31 or the aircraft maintenance manual. Again, though, this diagram is available readily on our website, so that if you need a quick look at that limitations, there it is. The other thing that we need to cover is the way they go on. They cannot go on with the oval against the length of the tube. So in other words, you got to have the length of the patch be parallel to the length of the tubes. And the reason for that is that rubber has to stretch, obviously whenever the boots are inflated. And rubber has tendencies so that it stretches better one way than it stretches the other. So you have that difference. And if you don't get the patch to stretch the same as what the de-ice boot does, you potentially have the possibility of the patch peeling. So as an example, this is a really horrible patch job on here because they put the patches on the wrong direction. They put patch on top of patch, so they haven't paid attention to the limitations as far as how many patches can be used in a square inch area. And so you'll see this, and this is a real situation. It really did happen. And this was the result of what happens whenever you do something like that. In this particular instance, the patches not being able to expand at the same rate as the de-icer started to peel up on the edges. And when that happened, because they were lumped on top of each other and everything else, when they gave in flight, it ripped the whole surface ply of the de-icer off. So this is why it's very, very important to adhere to this particular requirement. Again, if there's a broken stitch line, it has to be repaired. Cuts and tears that exceed 4 by 9 inches, it has to be, replaced. Broken stitch line, replace. Cuts and tears that exceed 4 by 9, replace it. Damage that exceeds the recommended repair guidelines, you have to replace it. And anything that penetrates the actual de-icer fabric, you have to replace that as well. Pinhole repair. This is something that you can put a patch on, but if you got a lot of pinholes, I would not recommend patches because you're probably going to exceed the limitations. In this particular case, we make a pinhole repair kit that is basically an epoxy that goes onto a little template that goes over the pinhole. You put that in place as long as the pinhole is a 16th inch or less. This is a two-part repair material, a buffing shield, and a template to put it all on. So it makes for a nice clean repair on the pinholes. You don't have the big patches showing up or anything. You just have little dots that are here and there, and you can buff those out to match up the de-icer itself. So this will take care of anything created, any pinhole created by FOD or by static discharge on the leading edge. So I'm going to get into a couple of questions that are primarily asked, but before I do, here is the information, and I'm sure you'll have access to this presentation afterwards as well. But this is the information for our technical support, product support, and any inquiries into the de-icing world. So, and of course, my information is on here as well if you have any questions about the presentation or anything else related to the de-icing and specialty heating products and product line that we cover here. We also have our Goodrich de-icing website specific or the overall Collins Aerospace website. So I'll take the last 5 minutes of this presentation, and I wanted to go over a couple of questions that we get mostly at these IA renewals, and I figured we'll go ahead and cover them now and try to answer them ahead of schedule here. So the majority of Goodrich products do not have a shelf life, and they're considered to be on condition. So Goodrich provides the information on what you should look for to determine if a product is still used. And this is an answer to what is the shelf life of Goodrich products. Most of them are considered on condition. So on our website, we do have the on condition statement that shows you what you should not will see on a product if you're wanting to use it and have a question as to whether it's still good. The same with the de-ice boots. We've covered that already. And when inspecting prop de-icers, you want to make sure that the active area of the heat or the heating area of the de-icer is flexible, smooth, and soft to the touch. So usually, most of the time when a rubber product is degrading, it's due to ozone damage. It's usually not UV. People think UV is what damages products, but ozone is the biggest culprit when you're involved with rubber products. Those of you that have seen dry rot, quote unquote, that's used or that is on tires that are old, the damage isn't because they're dried out. The damage isn't because of UV. It's because of ozone affecting the rubber and causing it to crack. So keep that in mind. What type of damage can occur on my de-icer? Well, according to our service newsletter 05-064, we do provide definitions that are really helpful in describing damage that you would see on a de-ice boot. So if you have a problem, you want to call us about that problem, you can access this service newsletter on our website, and that will tell you what you would be telling us in any kind of a conversation we have about that. It'll give you descriptions and examples of what the damage is, and it'll include guidelines for return of a de-icer and how to make a warranty claim if you need to do so. So it's available on Goodrich Tech Pubs, but it's also available on our website as well. So the damage that can occur, well, whenever you do the repair, this is something I'm seeing a lot when I get out in the field. We're seeing a lot of people using PRC. I mean, PRC is expensive, and I know they don't want to throw it away, but you cannot, absolutely not, use PRC for repairs on a de-ice boot. It doesn't have any flex to it. It's very rigid, and it's rough, and it will create ice adhesion points on the de-icer. So it actually will cause the de-icer to ice up more so than if you didn't use anything at all. So do not use PRC to repair your de-icers. Can I treat and shine my de-icers with 4-wax or auto wax? No, you cannot do that. That is harmful for the de-icer material. Usually it'll craze the de-icer, as you can see in the picture on the right. You only want to use what is approved by us, in this particular case, for our de-icers. That's called out in 30-10-31. Okay, so I'm getting a lot of pinholes in my de-icers. My runway's clean. I don't fly into anything with questionable runways. Why am I getting these pinholes? Well, here's what they look like up close. Here's what a pinhole with foreign object damage looks like. Here's what a pinhole with static discharge looks like. One's a cut, one's a melt. If you get melting occurring, a static discharge, it most likely means that you need to check your edge sealer on your de-ice boot to be sure that everything is properly sealed, because you're probably getting the discharge occurring because the electricity is not bleeding into the aircraft frame. So make sure that you're looking for the edge sealer issues. If you're seeing the melt holes, if you look at this under a loop. I think this is warrantable on my warrantable damage on my de-icers. It happened on all of them, is it? Well, what you're seeing here is something not covered under warranty. It's hail damage. Anytime you see circles or C-looking shapes, that would be hail damage on the de-icer. It's not a warrantable thing, but it's something to be cognizant of because we see it more often than what you would think. So if you see something like this, it was created by hail damage, somebody flying through a hailstorm or a thunderstorm. So yeah, we have these service newsletters. We have the 30-10-31 maintenance or repair manuals. These are things that you can certainly get into on our website, and we would highly recommend you do so to review everything that I have just gone over in this presentation. So that said, I thank you for your time and your attention. And again, don't hesitate to get a hold of us in any way, shape, or form if you have any questions at all. I appreciate it. Thank you very much.